Greetings, my name is Michael Pravica. I'm a professor of physics here at the University of Nevada, Las Vegas. And I'm extremely concerned as an American and as a physicist about the recent spikes in the coronavirus cases as well as deaths. And I wanted to make a video just to explain two brief concepts related to reducing the dose for the coronavirus. And the first one will entail using masks, why we want to wear masks. You see here two cloth masks, nothing special that would be typically worn by somebody. And what I want to demonstrate is if you can imagine somebody is infected, and let's say they sneeze or they cough, and they're on the left, your right side here. And so if you can imagine, they're going to cough and sneeze, and then there's a second mask, a recipient's mask, and you can adjust the distance here, it's nothing special. And the recipient, the unfortunate recipient, is very near where this person sneezes or coughs. So what I'm going to do is a very simple demonstration where we're going to squirt an imaginary respiratory droplets via this squirt bottle, and I have Coke inside, the darkest thing I could find. So we'll imagine that this is an aqueous based, which it is, material, but it's got these virions, these coronavirus virions, and that's what makes it black. If you just again, it's imaginary, but just so you can visualize. So we have somebody that coughs. Okay, so they cough for whatever reason right in front of this person. So let's see what happens. Okay, so that's a real good cough. So as you can see, the mask is slightly darkened. There's a spot there, okay, and spots here. And on the other side, it's completely dry. I don't feel anything. Maybe very slight moisture, but no darkening of the mask. Let's try it again. Okay, so you can see some dark areas here, right there, okay? Here, I don't see anything. Okay, so what is the message? The message is very simple. Let's suppose that this person coughed, again, just a number off the top of my head, maybe 100,000 virions, okay, of this deadly pathogen. Maybe this person received less than 1,000. So this person was likely their life was saved because they didn't get the full 100,000 virions. Maybe they got less than 1,000, and their immune system was able to overcome the onslaught. So the key is to reduce the dose, and in this case, we have definitely reduced the dose because these droplets were mostly absorbed by the infected person's mask, and very little, if any, I don't feel anything at the moment. I'm not saying that there's not anything, but I don't feel any moisture on this mask from the recipient. So we may have saved the life of the recipient. The second concept I just wanted to briefly talk to you about is the idea of distance, social distancing, okay? And really where it comes from is that if you can imagine somebody coughing without a mask, they're going to mostly dump the virions, the particles, the respiratory particles laden with virions, with the virus particles, in a sort of a hemisphere surrounding them, okay? So if you can imagine that hemisphere, and that hemisphere, as the particles go outward more and more, there's a radius of that hemisphere, and that radius expands. There's a formula for the area of a hemisphere is 2 pi times the radius squared. So what you can see is that as the further and further distance you are, the more and more hemispherical shell that kind of envelops all of these ever-expanding virus particles, the respiratory droplets with the virus particles. And so the intensity of the particles is basically the number of particles divided by that surface area of that hemisphere, which is essentially, in other words, as the bigger and bigger the radius, the more and more the area, so the density is reducing for the same number of virus particles. So the point is, the dose reduces. Since the dose would go through your nose or your mouth, that area is constant. So the point is, as the density of the dose decreases the further and further you are away, you're receiving less dose. So just to give you a simple way to see this, if somebody's at 6 feet of distance, and let's say somebody, again, coughs, okay? And so they cough, and all of these particles now, they receive, let's say, 1,000 particles because they were here, because this other person is twice as far away. They're 12 feet away versus 6 feet. They receive 1/4 the dose because it's depending on 1 over the distance squared. And so therefore, they're going to receive, instead of the 1,000 virions, they're going to receive 250, which is considerably less. So the point is, social distancing works from a very simple physics perspective. It is essentially that everything is depending as 1 over the distance squared. So it's very dramatic. The further and further you are away, the less dose you received. So in coupling this with mask usage, coupling this with social distancing, coupling this with when you're feeling sick, please don't go out and spread the virus. We all can beat this. We all can overcome this spike, bring it down, so we won't have to shut down our economy and lose ever more of our freedoms. Thank you so much for your attention. Please wear a mask. Please social distance. Don't go out when you're sick. Thank you very much for your attention.